Hello everyone, welcome back to Corona AP Maths. This pesky thing drags on and on, but we continue. So just a reminder of a couple of things. On your info sheet you're given all the stuff over here. You need to be really comfortable with that even though it's on the information sheet. And remember your log laws, if you've got ln x to the n, it's the same thing as n ln x. Okay, ln, remember that ln is log base e. Okay, ln of a over b is equal to ln a minus ln b. Okay, a bit of a wobbly board in our new venue. Okay, ln a times b, okay, will be equal to ln a plus ln b, and remember you've got to be able to work in both directions. Ln a minus ln b is the same thing as ln a over b. Ln a times b is the same thing as ln a plus ln b. Okay, there's no law for log a times log b. And the derivative of so now what we're going to start with today is differentiation of e and ln. So differentiation of exponential functions base e, okay, and differentiation of log base e. And the fundamental thing about e, okay, what makes it particularly interesting is that the exponential graph e to the x, everywhere on that graph the gradient is the same thing, is the same value as the function value. In other words, your gradient at that point is the same thing as the y value of that point. So in other words, the derivative of e to the x is simply e to the x. And that's given on your information sheet. So the derivative of the exponential function base e is the function value. The derivative of ln x is equal to 1 over x. Now it is implicit, okay, that x is bigger than 0, but you should actually get into the habit of writing that down. Otherwise ln x wouldn't exist. So the derivative of ln x is 1 over x on condition that x is bigger than 0. Right, so now we're going to do some examples of differentiation, okay, with e and ln. And again, all our rules, chain rule, product rule, quotient rule, still apply. So if you have the derivative of e to the f of x, okay, in order to do this we're going to have to use the chain rule. Okay, so give it a go. Okay, and what we do is we consider e of that whole thing the outside function. So the chain rule says the derivative of the outside function times by the derivative of the inside function. Remember, the chain rule says that the derivative of f applied to g of x is equal to the derivative of the outside function f dash g of x times by the derivative of the inside function. That is the chain rule. Okay? So the derivative of e f of x, okay, well the derivative of the outside function, or e to the anything is just the same. So it'll be e to the f of x. That's the derivative, okay, of the outside function. So the derivative of e to the f of x, that's the derivative of the outside function, times by the derivative of the inside function, and the derivative of the inside function is going to be equal to f dashed of x. So it's e to the f of x times by f dashed of x. The derivative of the outside function times by the derivative of the inside function. What you're simply using there is the chain rule. Okay? So right, based on that, go try to work out the derivative of e to the 7x. Give it a go for the sake of the show. Right. So the derivative of e to the 7x, the derivative of e to the anything stays the same. So it's going to be e to the 7x times by the inside function is 7x. So times by the derivative of 7x, okay, which leaves me with e to the 7x okay, derivative of 7x. You can skip out steps once you get comfortable with it, times by 7, which is 7e 7e to the 7x. Okay, so again, that's the derivative of your outside, e to the 7x times the derivative of your inside, the derivative of 7x is 7, so I get 7e to the 7x. Right. Now, the derivative of log base e, in other words, the derivative of ln x, is 1 over x on condition that x is greater than 0. So here, once again, we're going to apply the chain rule. Okay, the outside function is ln, the inside function is f of x. So the derivative of ln applied to f of x, okay, is going to be equal to, okay, the derivative of ln of a function is 1 over that function. So it'll be 1 over f of x, 1 over f of x. Okay, that's the derivative of your outside. Okay, times by the derivative of your inside function, so in other words, times by f dashed of x. There is a restriction though, so if you want, you can simplify it to f dashed of x over f of x. Okay, and you can just leave it like that. The restriction is that what goes into a log function has to be bigger than 0. So if they're asked to find the domain of that, f of x would have to be bigger than 0. Okay, so based on that, okay, so the derivative of the outside function times by the derivative of the inside function. Okay, the derivative of ln 7x. Okay, go try that then. So the derivative of ln of a function is going to be equal to 1 over 7x. Okay, that's the derivative of the outside times by the derivative of 7x. You can skip out these steps. And the derivative, so I'm left with 1 over 7x times, the derivative of 7x is 7, so I'm left with 7 over 7x, which is going to be 1 over x. Right. Make sure you get all of that down, please. Greetings and salutations. Right, so the next one, okay, give these a try. The derivative of ln ax, the derivative of ln x cubed. First I want you to try doing the chain rule. Then the same question, the derivative of ln x cubed, but I want you to first apply log laws and then differentiate. Okay, so try those three and then come have a look at the solutions. So the derivative of ln ax, well, you've got a function within a function, the inside function is ax, so it's going to be equal to, the derivative of ln of a function is 1 over x, so in this case it's going to be 1 over ax. Okay, your restriction is ax is bigger than 0, in other words x must be bigger than 0. So that's the derivative of the outside function times by the derivative of the inside function, which is the derivative of ax. So you're going to be left with 1 over ax, derivative of ax, so you can skip out steps, is going to be times by a. Okay, x is bigger than 0. And I'm left with a over ax, which is simply 1 over x. So the derivative of ln ax, no matter what that number is always simply going to be 1 over x. Derivative of ln 22x is going to be 1 over x. Derivative of ln 5x is 1 over x, or whatever. Ln kx will be 1 over x. Right, so first here, I don't want you to use the log laws first. Okay, I want you to just use the chain rule. So using the chain rule, this is going to be equal to 1 over that function, so 1 over x cubed, okay, times by the derivative of the inside function, which is the derivative of x cubed, okay, and the derivative of x cubed is 3x squared, so that'll be at the top, so it'll be 3x squared over x cubed, which is going to be 3 over x, and our restriction, which is done in the beginning, is that x cubed has to be bigger than 0, and for x cubed to be bigger than 0, x has to be bigger than 0. So you end up with 3 over x, where x has to be bigger than 0. Okay. If I use the log laws first, okay, and you'll generally see often it is easier to use the log laws first. derivative of ln x cubed, well, I'm allowed to move that 3 to the front. So it becomes the derivative of 3 ln x. Okay, so it'll simply be that constant will stay in the front. 3, the derivative of ln x is going to be 1 over x. Okay, again, x has to be bigger than 0. So it's going to be equal to 3 over x, given that f is, there's your solution. Okay, when I use the log law first, same answer if I used the chain rule first. Okay. Just now over here, if I said you go find the derivative of the ln absolute value of x, well, the only thing x can't be is x cannot be 0. Otherwise, there's no restrictions on x. So derivative of the ln absolute value of x, if you get a question like that, you don't have to worry about the restriction in terms of bigger than 0. It's just going to be equal to 1 over x. Okay? And the derivative of ln absolute value of g of x, well, g of x couldn't be equal to 0. Okay? But otherwise, you're going to just simply say it's going to be equal to 1, using the chain rule, over g of x times by, so it'll be 1 over g of x times by the derivative of the inside function, which is g dashed of x. And if you want, you can simplify that to g dashed of x over g of x. Okay? Lovely stuff. Make sure that all makes sense. Yellow. Right, try these two quickly on your own. Okay, sorry. The first one is the derivative of e 3x squared plus 7x. Okay, and then the next one is the derivative of 5 ln 6x cubed. Right, try both of those. So, the derivative of e to the f of x is simply going to be e of the original function, so it will be e 3x squared plus 7x times by the derivative of the inside function, which is 3x squared plus 7x. Right? So that's going to stay the same. So it's e 3x squared plus 7x times by the derivative of 3x squared plus 7x is going to be 6x plus 7. So that's your final solution, 6x plus 7 times by e to the 3x squared plus 7x. Okay? Right. The next one, derivative of 5 ln 6x cubed. Well, don't forget 6x cubed has to be 0, bigger than 0, so x has to be bigger than 0. Okay, so that's your restriction. Okay. Right, the derivative of 5 ln 6x cubed. Well, always, you can do it both ways. You can use the chain rule or you can use the log law first. I think I'm going to use the log law first. So in other words, it's the derivative of, I can move that 3 to the front. 3 times 5 is 15. So I get 15 ln 6x cubed. Okay. Sorry, 15 ln 6x. I'll move that to the front. Okay, and now I can go differentiate that. So it's going to be the constant in front, 15. And the derivative of ln 6x, well, it's going to be 1 over x, but if you've forgotten that, it's going to be 1 over, if I use the chain rule, 1 over 6x times by the derivative of 6x, which is 6. In other words, it's going to be 1 over x. So you end up with an answer of 15 over x. Okay, get that done. Okay, next one. And Morgan, I need you to pay attention and I need you to try and do that one on your own first. You're going to do it for the class. The derivative of ex squared times 5 over e to the 4x squared. And then Raisa, okay, stop WhatsApping various other people and I want you to try this one. The derivative of ln absolute value of x to the 4 2x minus 3. Okay, try both of those two. Right, so Morgan, the first one was yours, and no doubt you did this. Okay, so, well, I'll simplify it first. So it's going to be 5 e to the x squared divided by e to the 4x squared minus 4x squared. So you don't have to show that step. e to the x squared minus 4x squared, which is simply going to become the derivative of 5e negative 3x squared. Okay, and if I differentiate that, okay, it's going to be, well, the constant just stays there, 5, the derivative of e to the anything, it stays the same. So it's e to the negative 3x squared times by, again, you can skip out the steps, the derivative of negative 3x squared, which gives you 5e to the negative 3x squared, and the derivative of negative 3x squared is negative 6x, and if we make it pretty, we get negative 30 x e to the negative 3x squared. Let's just check that. So e to the x squared minus 4x squared, 5e negative 3x squared, stays the same, 5e to the negative 3x squared times the derivative of negative 3x squared, which is negative 6x, which becomes negative 30x e to the negative 3x squared. Okay, well done Morgan, no doubt you got that right, because you're an extremely gifted prodigy. Right, Raisa, okay, the derivative of ln x to the 4 2x minus 3, well the absolute value just means that there's no, we don't have to worry about the restriction really. So you're not going to have to solve where 2x to that whole thing is equal to 0. So just leave that restriction, and it says generally with complicated restrictions they'll specify in some way or other if you've got to go find out what the restriction is. So the derivative of ln x to the 4 times 2x minus 3, the absolute value of that is, well, simply times it out first. So it's going to be the derivative of ln absolute value of 2x to the 5 minus 3x to the 4. Okay, and the derivative of ln of a function is 1 over that thing, so it's going to be 1 over that function, which is 1 over 2x to the 5 minus 3x to the 4, okay, times by the derivative of the inside function, derivative of 2x to the 5 minus 3x to the 4, which is going to give you, remember that's over 1, so you times the top times the bottom, and the derivative of the top bit over there is going to be 10x to the 4 minus 12x squared, minus 12x cubed, am I right? 10x to the 4 minus 12x cubed, all over 2x to the 5 minus 3x to the 4. Okay, 10x to the 4 minus 12x cubed, or 2x to the 5 minus 3x to the 4. Just times the top times the bottom, remember that's over 1. Okay, lovely stuff. Okay, next sum, let's have Nicole doing this one. So you've got f of x is equal to ln absolute value of 3x plus 7 over 5 minus 4x. Okay, first question I want you to do, A, find the domain of that function f, and B, differentiate f of x. Give it a go. So, for the domain, well, the top can't be 0 because log of 0 doesn't exist. So 3x plus 7 cannot be 0. So x cannot be equal to negative 7 over 3. Okay, that's your first restriction. And then the denominator can't be 0 because the whole thing will be undefined. So 5 minus 4x cannot be equal to 0. So 5 cannot be equal to 4x. So 5 over 4 cannot be equal to x. So your domain of the function is x can be anything. I don't have to worry about that being negative because it's an absolute value, except x cannot be equal to negative 7 over 3 and x cannot be equal to 5 over 4. So there is your solution. You wouldn't have to show any working, okay, as long as you get that final solution correct. Right, the next one, go differentiate that. Well, we've dealt with any restrictions over there, so we just have to worry about the differentiation part of it. And the derivative of ln of a function is 1 over that function. So it's going to be equal to 1 over 3x plus 7 over 5 minus 4x. That's the derivative of the outside function. And you've got to multiply that by the derivative of the inside function. And to do that, to this part over here, you're going to have to use the quotient rule for differentiation. Okay, so go simplify that, go do that if you haven't done it. Okay, and if I've got 1 divided by that, flips around, so it becomes 5 minus 4x over 3x plus 7. Okay, right, and now using the quotient rule to get from here to here, I say the derivative of the top, well, the derivative of 3x is 3. Okay, so the derivative of 3x is 3 times by the bottom, which is 5 minus 4x, minus, then the derivative of the bottom is negative 4, times by the top, which is 3x plus 7, all over 5 minus 4x all squared. Okay, right, so just going to make that prettier. And if I make it prettier, I end up with, well, you're going to have 5 minus 4x squared is you're going to leave you with 1 5 minus 4x at the bottom. And you're also going to have 3x plus 7, that 3x plus 7 still at the bottom, because that cancelled out. At the top, you're going to have 3 times 5 is 15. Let's just simplify. 15 minus 12x plus 12x. Okay, and then you're going to have plus 4 plus 28. So you're going to be left with 43 over 3x plus 7, 5 minus 4x, and Nicole, I'm absolutely sure you got that all right. Okay, high five yourself. And if you made a mistake, just check where you went wrong. So your final answer, 43 over 3x plus 7, 5 minus 4x. Okay, rat bags, last sum. Example 13, f of x is equal to ln x squared. Question, first of all, is go sketch f. Rosina, you're going to do that. And B, Mogadishu, I want you to find the equation of the tangent to f at x is equal to negative 2. Right, so first of all, go do the sketch. To do the sketch, you have to think about the domain, the vertical asymptote, and the x-intercepts. Right, press pause and off you go. Right, so your domain, well, that's always going to be positive. So the domain is x can be anything, but x cannot be 0. Okay? And so you're going to have a vertical asymptote at x is equal to 0. So we're going to have a vertical asymptote here at x is equal to 0. The x-intercepts, well, you can intuitively, and you can think ln of 1 will be equal to 0 and ln of negative 1 will be 0, or you could go through the process and go 0, solve the equation, is equal to ln x squared. So we could say e to the 0 is equal to x squared, so 1 is equal to x squared, so x is equal to plus or minus 1. Okay, just using the definition, 0 is equal to ln x squared, that's log base e, so e to the 0 is equal to x squared, so 1 is equal to x squared, so x is plus or minus 1. So the two x-intercepts are at negative 1 and at 1. Okay, because x is plus or minus 1. And you just got to show that the graph, get the shape right, roughly speaking, flattens out, heads towards the vertical asymptote, and and flattens out, and this is the graph of f of x is equal to ln x squared. Okay, right, and no doubt, Rosina, you got that right. Mogadishu, UK. I want you all, okay, and then she'll come explain it to the class, to work out the equation of the tangent to the curve f of x is equal to ln x squared at x is equal to -2. There are 3 steps. You need a point, you need the gradient by subbing into the derivative, and then you can go use y is equal to mx plus c, or y minus y1 is equal to mx minus x1. Give that a go. So your point, well, if x is equal to -2, y is equal to ln of -2 all squared, which is simply ln 4. Okay, I'm not going to evaluate that at that point. So the point we've got on the curve that we're working with is the point -2 ln 4. And what are we trying to do? We're trying to find the equation of the tangent at that point. So there's -2 ln 4. You can go work out ln 4 if you want, but generally it's better to leave it in that form. Okay, so I've got -2 ln 4. I can see I should get a gradient that is negative, but let's have a look. So to find the gradient, I've got to find the derivative of ln x squared. So f of x is equal to ln x squared. So f dashed of x is going to be, well, we can either go use the log rule first, or you can use the chain rule. I'm just going to use the chain rule, doesn't really matter which one. So it's going to be 1 over x squared times the derivative of the inside function, which is 2x. Okay, and you end up with 2x over x squared, which is 2 over x. So your derivative equation is 2 over x for the function ln x squared, but we want to find the gradient at x is equal to -2. So the gradient is equal to f dashed of -2, which is 2 over -2, which is -1, and that looks good, okay, because the gradient looks like it's a decreasing function. It must be going left to right down, okay. And your last step is to combine the 2 bits of information. If we use y is equal to mx plus c, well, we know the gradient is -1, so y is equal to -x plus c. Okay, and now we can sub in our point. Our point is -2 ln 4. Okay, so I end up with ln 4 is equal to -2 plus c. So that becomes plus 2. So ln 4 minus 2 is equal to c. Okay, so your final answer, y is equal to mx plus c, is going to be y is equal to -x, m is -1, plus ln 4 minus 2. And if you simplify that, if you wanted to give it to 3 decimal places, you'd end up with y is equal to -x minus 0,614, which tells you that this tangent would just cut below the axis over there. Okay, very nice. Check this in autograph. I'll send you a picture to show you that indeed this over here is the tangent at x is -2. Okay guys, all that's left to do is from your textbook, Calculus and Algebra, Mind-Born Maths, exercise 8, page 278, A to I. I will send you those solutions. Hope you are surviving your lockdown and that you're not going absolutely balmy and you haven't murdered any of your family as of yet. Goodbye.